Anurag from Avail. I'm one of the co-founders of Avail along with Prabal Banerjee. So actually I entered crypto back in 2017. That was when I founded Polygon.
Ethereum had scaling solution issues.
So essentially, the philosophy was always how to scale Ethereum. If you see all the blockchains that were created after 2014, all of them are in some way variants of Ethereum. Different players build different parts of the stack and then they come together to provide this scalable solution. So Ethereum has been by far the most successful blockchain in the history of blockchains apart from Bitcoin, for example. Right? Blockchains are undergoing this shift in architecture from monolithic to modular.
And what did Rollups do to the ecosystem?
Initially, people were expecting there to be maybe a dozen rollups. Now already you can see hundreds of rollups, and this number is going to only grow. They can be very custom built, right? You can have an app function as a rollup, for example. You can have an NFT rollup, which is very lightweight to run. Really, Avail is infrastructure for the rollup-centric future.
Hi, hello, and welcome to the Decypher podcast. We're glad to have you here today. Can I start off with an introduction? Who are you and what do you do?
Hi, Anurag from Avail. I'm one of the co-founders of Avail along with Prabal Banerjee. Avail is a new kind of blockchain that's meant to power the roll-up-centric future for blockchains. And certainly I will go into much more detail in this discussion.
Obviously. Yeah, phenomenal. I'd love to get to Avail. We're obviously going to cover Avail in great depth today, but I am curious to learn a little bit more about you. So I guess, first of all, how did you even get into crypto? How did you arrive to the space?
Yeah. So actually, I entered crypto back in 2017. That was when I founded Polygon, or Matic, when it was known back then. Before that, I spent about 11 years in fintech and regulatory tech sort of spaces in product and engineering roles. In 2017 is when I actually entered crypto. It's been like 7 years now. So, but at the time, Ethereum was going through one of its first scaling phases. So there was a lot of congestion and stuff like that. And the Plasma white paper had just come out. So me, Sandeep, and Jayanti, all three of us decided to build out the first scaling solution for Ethereum, and that's really when I entered the crypto space. Before that, I was in traditional fintech and regtech sort of roles, had dabbled a little bit with private blockchains and such for financial institutions. But yeah, full time I entered crypto in 2017.
So I think this is a really interesting piece of crypto history because Avail builds for kind of the future and Polygon was building for the future at the time. So it's interesting to compare the two as kind of both independently solving the problems of their time. So basically, Polygon was building a layer 2 solution because Ethereum was, costly. Ethereum had scaling solution issues. So Polygon came along with the thesis that there needed to be Ethereum-aligned scaling and created a chain for such. Is that fair to characterize kind of the world of Polygon?
Yeah. So, like while I was at Polygon, so when we actually started Polygon, the first problem that we took on was how do we scale Ethereum? And before Rollups, Plasma was this solution, which is, you can think of that as a precursor to Rollups. So essentially, we started off with that. Ultimately, after 2.5-3 years, we understood that Plasma solutions wouldn't be realistically feasible, and so that's why even at Polygon we pivoted to ZK Rollups. You can see already. Polygon launched the ZK EVM last year, for example, and so on. So, I mean, from a progression journey, we started building the Plasma solution, but we had to pivot to the Polygon POS because Plasma was not realistically feasible. But after kind of, providing Polygon POS to the ecosystem, which is pretty successful, we focused on building the true layer 2 solution, which is the ZK rollup space. So I built a lot of the Plasma stack, the Polygon POS stack, the bridging infra, and so on also was pivotal in kind of like acquiring ZK competencies at Polygon, including acquiring Hermes, Zero, Maiden, and so on. So essentially, the philosophy was always how to scale Ethereum. I mean, it's not only a scaling Ethereum problem, and that's how like Avail also came about in general. Like what we believe fervently is that layer 2 solutions or rollups or however you might categorize those are the future way of how blockchains will evolve. In general, like if you kind of see the first blockchains, like Bitcoin was the first blockchain, Ethereum was the first general purpose blockchain, and those are all built using these monolithic blockchain constructs. And if you see all the blockchains that were created after 2014, all of them are in some way variants of Ethereum, whether they be EVM chain with faster blocks or EVM chain with lesser block times, for example, or even something like Solana or EOS, for example, which have different virtual machines, have a lot of things. But ultimately, these are all examples of monolithic blockchains, everything happening on a single system. And really, when we look to scale Ethereum, we are also looking at it in a more modular construct. So what we are saying is that as blockchains have evolved, as with any technology industry, the first it is like made in a very monolithic fashion, but then you kind of specialize, you get more and more specialization. Different players build different parts of the stack, and then they come together to provide this scalable solution. And so that's really the bet that we are taking at Avail, that blockchains are undergoing this shift in architecture from monolithic to modular, and we build infra for enabling that modular future.
So talking about Ethereum just as the base layer, Ethereum in 2017, let's say. So Ethereum had 3 layers essentially built in. Monolithic means that it had 3 layers built into it, and that's data availability, settlement, and execution. Then we saw Rollups come along and, 2020, 2021, and what did Rollups do to the ecosystem?
Yeah. So, I mean, let me again, kind of take this, I like this analogy very much. So generally with the evolution of every technology, this happens all the time, right? Like, so this analogy I generally try to give is of this motorcycle manufacturing. Like, so if we kind of think about how the first motorcycles were manufactured, they would ideally be manufactured in the same factory. The wheel, the engine, the tire, like everything would be made, in the same factory. But as the technology matured, you get into specialization, right? Like, so there is a wheel manufacturer, there is an engine manufacturer, there is an electronic dial manufacturer, and so on. And all of these coordinate together to create a motorcycle or a car or any other product or any other, so it happens in every technology and industry that the first iterations are always very monolithic. Everything is made in the same place. But then over time, you specialized players emerge. They take care of specific parts of the stack and optimize for that, right? Like, so in the same way as you mentioned, like broadly speaking, a blockchain has these 3 components, which is execution, settlement, data availability. And if you kind of try to look at the mechanics, like what is really a blockchain, right? Like a blockchain is basically, if you kind of try to simplify it, it's like a essentially users send in transactions. Those transactions are put in certain order, and then there is some state transition function that is executed. So some logic that is executed, for example, right? Like, so if you kind of try to look at it from that manner, what you are trying with a blockchain is user send in transactions, someone decides the ordering of transactions, that is maybe the block producer, or where like the consensus mechanism comes into play, for example. So you need to define a certain order. Then you need to have some guarantee on that the order cannot be reverted back. And then you kind of run some sort of state transition function to make sense of those transactions, right? Like, so these are broadly the three parts, right? Like, so this broadly map to like the data availability component, the settlement component or finality component, and the execution component, right? Like, so you have a set of transactions, they are ordered in a certain way, you have enough guarantee that that order cannot be reverted back, and then you run the state transition logic. So these are the core parts of any blockchain.
Right.
And what rollups really do is essentially outsource the execution onto a specialized layer, and the base layer generally handles things like ordering and finality. So from a case of Ethereum, rollup on Ethereum, that's what really happens. Rollups take in transactions. You have, like, there are a lot of constructions possible in how rollups can be run. The most popular one today is a sequencer-led model. So there, the sequencer, as the word says, sequences those transactions and puts it into a certain order on Ethereum. That is what we generally know as data availability, although data availability is much more than that. And then Ethereum offers this notion of finality, in the sense that the particular order cannot be reverted back. And the rollup is really kind of like just an execution engine per se. So hopefully that gives enough color.
Sure, absolutely. I think it's important to understand the space broadly, so I think getting it from an expert is great, and then we can understand better how Avail fits into the kind of universe. So anyways, if I'm understanding correctly, we have rollups, which provide the execution environment, so you're transacting within the rollup, and then we have the settlement layer, which in this case would be Ethereum, so they're kind of providing the economic guarantee at the base layer, and then we have a third component, which is a data availability layer. And Ethereum can provide this data availability layer, but it doesn't have to. So what is the problem that Avail is solving, and how does Avail fit into this kind of picture?
Yeah, so I mean, so Ethereum has been by far the most successful blockchain in the history of blockchains, apart from like, let's say, Bitcoin, for example, right? Like, so it's been here for a long time. It's acquired a lot of legacy in terms of like strong cryptographic security, like a lot of high quality assets and such, right? Like, but people forget that it started off as a very simple idea, right? Like, the idea was that how can we kind of introduce general purpose logic into a blockchain. Like Bitcoin is I mean, if you get into nuances, Bitcoin has some sort of some limited programmability, but generally it is a blockchain that can do transfers, for example. And so Ethereum was the first big implementation that said that let's do programmable general purpose programming on this blockchain construct. And so it began as this relatively simpler blockchain, but over the years it has metamorphed into much more, right? Like, I mean, initially there was this proof of work mechanic and simple execution engine. Now it is much more complex. There are two different layers or clients. For example, on the Ethereum network, there is something called a beacon chain, then there is an execution chain. So there's a lot going on. But essentially, what has happened is Ethereum had to transition from a monolithic blockchain into a more modular sort of construction. In fact, Ethereum is the first modular blockchain per se, because like rollups were invented to scale for Ethereum, but essentially like it's really the bifurcation of or specialization of responsibilities on the Rollup and Ethereum. So in this case, to put it simply, Ethereum handles consensus and security, and the Rollup handles the execution part in general. Now the thing is, of course, like Ethereum is this high value chain running in production with hundreds and thousands of validators securing hundreds and in billions of assets, and it's very hard to change this system on the fly, right? Like it takes time. Changes are deliberate. They take time to get into production. They have to be tested thoroughly. For example, they have to go through a lot of community review, EIP review, for example, and so on. So, and the thing is that Rollups, the Rollup Centric roadmap, although it was announced in 2020, 2019, 2020, 2021, it has picked up pretty fast, right? Like, I mean, you already have production ready stacks like Arbitrum, Orbit, Optimism, OP Stack, Polygon CDK, ZK Sync, ZK Stack, Starkware, Madara, for example. All of these and many, many more that we've still in development, for example. And the pace of Rollup stack development has been so fast that initially people were expecting there to be maybe a dozen rollups. Now already you can see hundreds of rollups already, and this number is going to only grow. We are just talking about EVM style rollups. There are more, like there's no compulsion for rollups to be EVM centric. They can be any execution environment. They can be very custom built, right? Like you can have an app function as a rollup, for example. You can have an NFT app, NFT rollup, which is very lightweight to run, for example, and so on. So, I mean, the idea is that the rollup construct is very powerful because for the first time in blockchain history, it allows you to bifurcate the pieces of code that are required to bootstrap an L1 every time. Like, so if every time you want to do a new chain, what you have to do is do this thing called cryptoeconomic security bootstrapping. You have to onboard a set of validators. You have to like do a new token. You have to ensure the token has value, for example, and that's a lot of work for an app developer to do. And so what rollups really bring to the fore is this capability to get security or inherit security from this base layer and then focus on their app logic. And so how Avail really comes into this is because the number of rollups are increasing exponentially, there is a clear requirement for scale in terms of data availability, for example. Data availability on Ethereum at the moment, even after, the Ethereum went through a proto-dank sharding upgrade recently, and there is this longer term roadmap of dank sharding, but that's going to take some time. And so rollups are not really able to wait for that upgrade. Like they need scale right now, and that's where Avail DA, which is the first component of Avail that comes in, that just provides data availability at scale using validity proofs, and that's the core need that it fulfills today. But Avail is not only a data availability layer. We also build additional components on top that are made possible by this foundational layer. This is called Avail Nexus that we are building on top of Avail DA. And if you look at kind of Ethereum today, it's there's like this whole different set of rollup stacks. You see Optimism having this super chain ecosystem. You have ZK Sync having this hyperchain ecosystem. You have Starkware doing their L3 thing. You have Arbitrum doing their Orbit ecosystem. And so even though they are all part of the same system, they have different interfaces. They don't interoperate well with each other. You have to kind of go via Ethereum to interact across these chains. So if you are a user on Arbitrum, for example, you would have to go through Ethereum if you want to do something on Optimism, for example. I mean, you can use third-party bridges, but they are not as secure as the native bridge, for example. So I mean, I mean, there's a lot of nuance and detail to get into, but I'll stop at this time, like for any questions.
So maybe kind of at a surface level, you could say Avail is a data availability layer. And this exists because data availability is incredibly costly due to the economic overhead that exists on Ethereum, and we're solving for that, right? So that would be like the first component.
Yeah. That's. I mean, yeah. To simplify, that would be the first component. In general, of course, we've been building the Avail DA network for now 3.5 years. To give some history, actually, Avail started within Polygon in late 2020, and we spun Avail out of Polygon last year in March, and so this is like a hard engineering problem in the sense that it takes time to build the data availability sampling part. So certainly that is the main thing that we have been solving for now. But it's certainly it provides for inexpensive DA, but it also enables us to kind of build the next component, which is a much more unified Ethereum ecosystem, so to speak.
Right. So then the second component is this interoperable world where rollups are interacting with each other in a much more secure, efficient, and expensive way. They don't necessarily have to use Ethereum and the spend the Ethereum, what it takes to interact with Ethereum to interact with each other, essentially.
Yeah. We use clever techniques such as like proof aggregation, and data availability sampling to kind of we basically kind of provide an abstraction where we kind of, let's say, if there are multiple rollups, we will aggregate proofs from these rollups and then submit this aggregate proof to Ethereum, for example. So it just makes things like interoperability much easier and cheaper.
Right. So tell us a little bit about that spinoff from Polygon. You guys started off internally with Polygon. Then at some point the decision was made to spin out, and you guys raised a really kind of blockbuster round around Avail. Can you tell us about that story?
Yeah, so when we started Avail back in late 2020, this was around the time when Ethereum had announced the Rollup-centric roadmap. Like, it became very clear to us that Rollups would be the future of blockchains in general, and I'm very passionate about that. And it became very clear that there needs to be a lot of infra built to enable this Rollup-centric future. So, like if there are these, if we are going to go into this world of thousands rollups or tens of thousands of rollups, you need to have infra to enable these rollups. You need to have things like data availability, sampling, data availability at scale, for example. When you have like probably 100 chains or so, you cannot expect users to be switching between like tens of chains, for example, or bridging tokens from one chain to another, for example. So you will need a lot of infra on top that supports this rollup centric future. So really, Avail is infrastructure for the rollup centric future. Essentially that was the thought process when we started Avail back then. Now what happened is over a period of time, I don't know if a lot of people remember this today, but at Polygon we ended up having a lot of products within the same umbrella. So there was the Polygon POS chain, there was something called Supernets, something called Edge, for example. There was Hermes, there was Zero, there was Maiden, something called Nightfall, which is more privacy focused chain, and Avail. There was even like Polygon ID. So just too many products within the same organization, and it's very difficult to manage this from an organizational perspective, in the same umbrella. Second point was that if you kind of look at Polygon's brand in general and the main focus for Polygon, it's to be one of the leading Ethereum layer 2 solutions, and like Avail is a very roll-up agnostic solution, right? Like we work with Arbitrum, Optimism, Polygon, zk Sync, Starkware, Scroll, and variety of other roll-up providers. And they, it might be a problem for other roll-up players to kind of work with us because of this, like conflict, like between the flagship L2 brand, for example, and their roll-up stack, for example. So things like that. Like, I mean, we wanted to position Avail as a very credibly neutral roll-up agnostic sort of platform, which would support all roll-ups, not only Polygon rollups, for example. So those were some of the reasons that we made the decision to spin out, and I left all operational roles at Polygon, been focusing on Avail since then.
Excellent. And then throughout that process, you kind of developed, going internal to kind of having a new kind of baby with its own ambitions. What would you say is kind of the Avail thesis, right? Obviously, building infrastructure for the rollup centric world is kind of the umbrella term, but what is the Avail thesis? What world is Avail building for?
Yeah. So as I said, right, like, I mean, essentially every technology goes through this, phase of evolution in terms of modularization, right? Like, so initially all these blockchains after Bitcoin and Ethereum, I mean, consider EOS, consider BSC, consider Phantom, Solana, all of these were different. These are, like different variants of like what a blockchain can be. But once rollups came into the picture, it became very clear that like rollups would be the main way that blockchains would evolve into. And to give an analogy, right, like apps on the internet are not hosted on one single big supercomputer, right? Like they are hosted on different servers. They are scaled independently based on demand, right? Like there's so many apps on the internet. It would be infeasible to think of hosting all those apps on one single big server. So why would blockchain apps be any different? Like, how can you assume that blockchain apps can just live on just one single network? That's not something that is like realistic. And so we kind of understood that change, and we knew that what would happen to blockchain apps would be that these would transition to, just like apps on the internet, like specialized apps that run on their own servers, are scaled independently based on demand and so on. And for that to happen, like you have to understand like how apps on the internet really scale, right? Like, I mean, apps on the internet, again, as I said, don't live on one single big supercomputer. They are basically like things called like microservices, for example, that work on a very asynchronous sort of model and are used like based on demand, right? Like, so just to make this more concrete, right? Like, if you're going to Amazon, for example, and buying a product, when you're clicking on the buy button, what is happening in the background is Amazon is, this request is hitting the Amazon servers. The Amazon servers is calling, let's say, the Visa microservice or the Stripe microservice, for example. It is sending you back a page where you enter your card details. When you submit your card details, that request hits the Stripe microservice, which then in turn hits a Visa microservice, which says whether the transaction succeeded or failed, for example. So all of this is happening behind the scenes pretty quickly, so that the user doesn't even notice. But there's a lot of complexity happening behind the hood, which users are not really exposed to. So what I'm trying to kind of arrive at the picture is that you have to kind of arrive at that sort of infrastructure and that sort of abstraction if you want blockchain apps to go mainstream. The kind of infrastructure and the kind of user experience that is there right now is basically very power user friendly. Like, power users will be at home at using, let's say, a MetaMask, or like switching between chains and like switching RPCs and so on, and which is fine for power users, for example, and so on, but it doesn't work for like if you want this technology to go mainstream. And so really what, of course, like as you said, on the technical bits we focus on enabling scale for rollups and having these rollups talk to each other. But the Avail thesis is really that the blockchain world is going to move from host all your apps on one big server to this world of apps being on different servers, scaled independently based on demand, just as the internet apps on the internet progressed. And that is really the end goal that this infrastructure building really will amount to. And so that's the thesis, right? Like, I mean, essentially.
So maybe a way to kind of put this in Web 2 terminology would be like, in the 90s there was AOL, and you went to AOL, and AOL kind of had concentrated services on its platform, which would be something like early Ethereum. Avail maybe is some type of, this is kind of a tenuous analogy, but maybe something like WordPress, right? Where it enables an ecosystem where people can build individually, yet they're unified into a single kind of infrastructure and flow. And Avail, along with providing data availability, which is an interesting value proposition in and of itself, it also kind of unifies the user experience, or has the potential to unify the user experience of people using apps in crypto.
Yeah, I think maybe if you want to simplify this you can think of this more like like a verifiable cloud sort of an offering. Like, so if you look at like how apps on the internet are generally like deployed or hosted, like generally like the developer will deploy on something like an AWS or a Google Cloud or something like that. And so these apps can be hosted here, and then you can make calls from one server to the other, for example. Of course, with blockchains, the paradigm is slightly different. The main benefit you get from blockchains is verifiability. So that's why I use the word verifiable servers, or rollups are really verifiable servers. Like you put some logic and you kind of have some way to verify whether that logic was executed correctly and so on. And so what we really do is provide all the plumbing to enable lots of these verifiable servers, so that like developers don't have to host their own servers. Developers don't have to, so the cloud analogy works better.
Right. Yeah. In that way, is Avail Ethereum aligned in your opinion? Because in one example, you're creating a potential for a universe of more user-friendly apps and cheaper transactions, but on the other side, you're taking away something from the economic model of Ethereum, which is right now data availability, which Ethereum generates a lot of revenue from that those costs. Is Avail Ethereum aligned? Do you want it to be? How do you think about that?
See, basically, I mean, there are different ways of looking at it. As you rightly mentioned, of course, we take away some of the fees that go from rollups to Ethereum directly from a data availability point of view. But like, if you kind of look at from a broader point of view, like I mentioned the examples, right? Like, if you look at some of the ecosystems emerging around Ethereum, like the Optimism superchain, for example, or Arbitrum Orbit or zk-Sting Hyperchain, for example. So all of these are kind of different ecosystems that are kind of evolving on top of Ethereum. So, like the Optimism set of chains or the superchain is distinct from the zk-Sting Hyperchain ecosystem, for example, or the Arbitrum Orbit ecosystem. And all of them don't necessarily talk to each other. It doesn't seem like a very unified Ethereum. It seems like a very fragmented Ethereum. And this problem is increasing day by day. And so what we really do when we say that, Avail helps scale rollups, it also allows us to build this notion of a more unified sort of Ethereum, for example. So in that way, I think we are, we very much kind of are complementary to Ethereum. I think it's foolhardy to compete against Ethereum in that sense, because it has so strong network effects. It has so much value on top. Like I think it's a much better strategy to kind of augment Ethereum and strengthen the rich ecosystem that it has, enable infrastructure and tools that help the infrastructure that has evolved around Ethereum, and the economics, that gets taken care of, right? Like, I mean, even if we take away some fees from a data availability perspective, settlement is still on Ethereum, for example. Proof verification still happens on Ethereum, for example, and so on, right? Like, so there's a bunch of things there. So I wouldn't view it as very black and white.
Going back to the tech layer of Avail, aside from data availability, there are two kind of other services, products, layers to Avail. One is Nexus, and the other is called the Fusion Security Layer. Can you explain these things to us?
Yeah. So what we are building with Nexus is really this verification layer on top of Avail. So it really, like, in technical terms, it's a custom ZK rollup that we build on top of Avail DA, and it's a very specialized sort of rollup. It doesn't do any smart contracts. The only purpose of Avail Nexus is to coordinate rollup state. So essentially, what the function of Nexus is, it basically listens to all these rollups that are operating. It kind of takes in data from these rollups. So you can think of as taking a snapshot from all these rollups. It already knows the transaction ordering for these rollups, and so you can think of it as an like a proof aggregation and state coordination sort of a layer. And so, like, if you kind of think of it, what is interoperable rollup interoperability? Like, if you want to kind of communicate from one rollup to the other, you need to know that the state transition of the other rollup is correct, for example. So what we do is, instead of each rollup verifying proofs of all other rollups it wants to communicate to, we just take in all the proofs, aggregate them into one single proof, and then basically any rollup can use this proof because that proof has already verified the state of other rollups. So again, not getting into too many technical details, but essentially, instead of each rollup having to talk to each other to verify whether it's correct, the state is correct, we basically introduce Nexus in between, so that you can then easily connect these rollups together. So really, Nexus is this interop enablement layer between rollups, and it's only possible on Avail DA because we build data availability with sampling with validity proofs, and this allows us to build much more secure interoperability solutions. So that's really Nexus. Nexus also has some other parts which I won't get into much detail, things like sequencer coordination and such, but getting to the fusion part, so we initially started thinking about building fusion because, of course, Avail is a new layer 1 blockchain, and as with any new layer 1 blockchain, it takes time to bootstrap cryptoeconomic security, because initially the cryptoeconomic security is based on the new token, and the new token takes some time to mature, for example, and to acquire enough value. And so we thought, we looked at a few inspirations like Osmosis, for example, in the Cosmos ecosystem, and EigenLayer and Babylon in the Bitcoin ecosystem, for example. And we thought, like, can we use this mechanic to add more cryptoeconomic security to Avail? And so Fusion really is the capability for people to stake non-native token assets. So you can think of assets like BTC, ETH. People can stake those to add to the security of Avail, and so we can like scale the cryptoeconomic security for the Avail base layer. So that's really what Fusion is. But happy to get into more details.
So two things come to mind. Two projects come to mind, and there are more. But two kind of name brand projects that come to mind when thinking about competitors to Avail are Celestia, which maybe competes with the data availability product around Avail, and then EigenLayer, which maybe competes with the Fusion security layer. How do you think about these competitors?
In general, I think certainly Celestia is a competitor in the from the data availability point of view. So they are the only other project that has implemented data availability sampling, although they implement it with a fraud-proof based approach, which is similar to like optimistic rollups per se. Like Avail is the only blockchain which implements data availability sampling with validity proofs. EigenLayer also has an offering called EigenDA, which is like a it's like a data availability committee. It doesn't really implement data availability sampling, for example. But like Avail is not restricted to only data availability, right? Like as I said, it provides like this. The Avail DA is the foundational part. It provides this interoperability component called Nexus in general, which is I don't think these projects solve for example. So in general, I think the Fusion security thing, it's not a competitor to EigenLayer per se. You can think of it as a consumer of whatever, let's say, an EigenLayer has to provide, for example. So EigenLayer or any other similar competitors like Symbiotic, for example, or like Karak, for example. So all of these, what they provide is they provide the ability to use assets like Ethereum, ETH, for example, or in the case of Symbiotic, they use like any sort of ERC20 token, for example, to kind of bootstrap a new service. So you can think of Fusion security more like a consumer of these services, like Symbiotic, like EigenLayer, in that sense. So hope that makes sense.
Yeah, absolutely. So this gets into a question around tokens. Avail, super recent token launch. How does the Avail token fit into the Avail ecosystem?
Yeah. So when we were designing the overall architecture, we actually thought about the token utility a lot. Like, of course, Avail is a decentralized blockchain, and like we focus a lot on the decentralization of the base layer in general. So one of the reasons that we implement something called Grandpa and Babe consensus. So this is basically technology that was implemented first by Polkadot, but we kind of modified it for our own requirements, for example, and so on. But we use something called nominated proof of stake to kind of power this, and Grandpa allows for today it allows for about 1,000 validators to kind of run the blockchain. In the future, we can scale it to 10,000 validators and more. And so the Avail token, first of all, is used as a staking token to power this base layer. It also used as a fee token to pay for services by Rollups, for example. But we don't stop at that. On the component on top of Avail DA, which is Nexus, that handles broadly two components. It handles the interoperability. It also handles things like sequencer coordination. And so the Avail token is also used for, let's say, paying bridging fees, for example, paying sequencer fees, for example, and so on. So we kind of have designed the Avail token to play a role in each part of the vertical stack. certainly it plays a role at the base layer, but it also plays a role in the execution layer from a, let's say, a sequencer point of view. From if it wants to, kind of people want to go from one chain to another or do a chain abstraction play, for example, it also kind of like used for the overall interoperability mechanics, bridging fees, and so on.
Right. So now to wrap up, I want to get into the future of Avail. What are your guys' goals, new products? How will Avail build out its ecosystem?
Yeah, so we've been, kind of already quite active, working with a variety of partners across Rollup stacks, across use cases, domains, for example. So we work with all the major Rollup stacks, including Arbitrum, Optimism, Polygon, zkSync, StarQuest, Scroll, variety of other Rollup players. So of course we are going to ramp up the rollups that are there on Avail DA. So that is our focus. We've already signed up a lot of rollups that are going to launch on mainnet pretty soon, since we've now launched already. We have been working with a variety of players across social, across finance, across gaming, commerce, and variety of IP, for example, and variety of other domains. So that certainly is one of the main focuses, is to kind of ramp up the number of rollups that operate on top of Avail DA. That's certainly the near-term focus. But of course, we are we are a very practical engineering focused team. Like our culture and philosophy is on kind of shipping rapidly. So we've been very hard at work at shipping Nexus and Fusion as well, which will come out in the next few months. So we are certainly working with a few early select partners to pilot Nexus on, for example, to ensure that you can have things like doing a transaction, triggering a transaction while you are on Polygon, for example, and that getting executed on zkSync or on Arbitrum, for example, and so on. So all those things are we are cooking up in our laboratory, and those will be out for use pretty soon. We are also kind of on the verge of announcing few key strategic partnerships that will push usage beyond typical Web3 use cases, for example, and so on. So yeah, lot of exciting stuff in the pipeline. We were just waiting for mainnet to launch for these other partners to launch on us. So that's out of the way. I think we should see a lot of action happening.
Phenomenal. I have one last question for you, and that's 5 years from now, 10 years from now, looking back on your journey with Polygon, now with Avail, what are your goals personally for the space? What could you look back on and say, wow, I'm incredibly proud of having achieved this?
Yeah. So as I said in the earlier part of the discussion, right? I come from a very I spent 11 years in fintech and regulatory tech, and I've been thinking about a lot of problems of I have a bias towards finance, but it's essentially down to coordination, right? Essentially, if you kind of look at it, blockchains are a great tool for social and economic coordination. So if you kind of think about how trust has evolved over time, if you let's say look back a few hundred years, humans used to live in small communities, and barely used to trust people from outside those communities. And how society and how the world has developed is that we have built systems in place that enlarge or increase this circle of trust, right? So especially after technology has come into play, the circle of trust, as we know, has only grown. So today it is possible for someone sitting in the US to order something from halfway across the world, from Japan, for example, and expect that the transaction will go through, the goods will come through, and so on. You could never envision this hundreds of, like 100 years ago, or even 30 years ago, for example, 20 years ago, for example. And so it's, if you kind of really look at it from that perspective, the lowering of these barriers of trust is what has allowed the world to develop at a very fast pace, allowed more people to benefit from, you know, interacting with each other. Now a lot of this is economic, but it's also social, right? Like, I mean, you and me are sitting halfway, you know, I'm in, you know, like in sitting in Dubai, you're sitting halfway across the world, and we are conversing with this, you know, like with this technology which allows me to speak to you without, you know, like getting on a flight, for example, and so on, right? Like, I mean, it just lowers the kind of barriers that you have for, let's say, social coordination or for economic coordination. And so the point I'm trying to get at is that there is still a lot of you know, like friction in terms in when you kind of think of people coordinating with each other, right? Like, you still coordinate with trusted intermediaries. I mean, how can we allow people to kind of do more sorts of economic coordination on their own in a more P2P sort of context, for example? Can 50 people of, you know, like band together and create like a lending cooperative, for example? Essentially, if you kind of look at blockchain technology, to build something like this, you need something which is not owned by one party, by a third party. It has to be, you know, like neutral, credibly neutral. And to enable this sort of infra at scale, for example, that's really the end goal that I am working with. This is my personal philosophy. It also applies to all the work that I do at Avail, for example, and so on. And so that's really the future that I look to accomplish with Avail, and in general the broader blockchain industry.
Excellent. That's a beautiful sentiment, and it's a really interesting perspective of looking at the work that we're all doing in the crypto space. Anurag, thanks so much for your time. I know you have had an incredibly hectic couple of weeks. Congratulations with mainnet, and thanks for coming on.
Yep. Thanks, Jack. You know, thanks for having me. It was lovely having this discussion.